Hello and welcome to this new video. In this short series I want to explain the details on Etherscan to you so that you are able to watch any data on Etherscan.io, which is a block explorer. I'm pretty sure when you are in the field of Ethereum you already have heard about Etherscan. So it's, as I said, a view portal to the blockchain, and you can view and watch data. So for example, when you go to Etherscan.io, this is the main page here, you can search for addresses, for accounts, for block hashes, transaction hashes, and all the stuff. You see some metadata here about the blockchain, so the current ether price, market cap, transaction count, the transaction per seconds, the median gas price, difficulty, hash rate, and all the stuff. And then you have two sections. So the left section is the latest blocks. So it's a list of the latest blocks that was mined or were mined. To the right, there are the latest transactions, which are part of the blocks. And as I said, I want to introduce you a little bit to this interface and how you can read data so that you really understand what is going on the blockchain, and that you can also verify transactions that you make from your wallet and make with smart contracts, so that you are familiar with how this is how this will be read here. For example, when we go to the so I hit refresh so that we have the latest state. So for example, the latest block that was mined is now 20 seconds old. Its block height is, what is it, 15,108,332, which is the block height, so the number. So there are 15 million blocks in the blockchain. And you see the miner here, this is an address. You see that it contains 179 transactions, and that the reward is 2.13 ether. And you can then click on this block and you see all the information that is available. So for example, the block height, as I just mentioned, the timestamp when this block was mined. You see it contains 179 transactions and 51 contract internal transactions. I will go into the details here in a few minutes. You see that the miner with the address 0xAB and ending with 8C83A has mined the block 7 seconds ago. I think this needs to be, so in 7 seconds, yeah, this means 7 seconds from the previous block to this block. The block reward is 2.13459 blah 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 ether, which is calculated by 2, which is the static block reward. So for every new block there is 2 at the moment, 2 ether. And this is the transaction fee. So all the transactions, 179 transactions together, pay a fee of 0.2238 ETH. And this is slightly reduced by burnt fees. So this kicked in with EEP 1559, I think that's the standard. So when Ethereum became deflationary, and where some minor fees are getting burned in order to keep the fee and the gas war and the fees structures more stable. So next, what is interesting is the difficulty. So this is a target of a cryptographic hash puzzle that needs to be solved. Total difficulty, the size in bytes. So how many data actually is stored in the block? It's 69,382 bytes. So what else is interesting? The gas used and the gas limit. So I made one post on LinkedIn and Twitter that so for example, in Bitcoin, the block limit, so the amount of data that can be stored in one block, is determined by the transaction count. And in Ethereum it's different. It's based on the gas usage. So all the transactions together, the gas that is used for all the transactions will be summed up, and one block can hold 30 million of gas. And for example, this 179 transactions together consumes 15,233,412 gas. So it's 50% almost. And there could, so when the other, so we could almost double the transaction count. So this could be 360 almost. when the remaining 180 will be the same as the existing 180, then you could store up to the double amount of transactions. But this really depends on the transactions and on the on the code execution that happens based on these transactions. And the gas, as I said, is allowed to sum up to 30 million, and we are here with 50 million. So this is for the EAP 1559. This is the standard where Ethereum became slightly deflationary. So this is the gas, the base fee per gas. This is the amount that is getting burned, and this is then the total ether that is getting burned. So 0.089 ETH were getting burned here with this transaction, and you see that, with this block, and you see this number is exactly the same as this number above here. And you see additional data. So for example, who has mined this block? It was a pool, so a mining pool, pooling.com. You can head over and can have a look at this mining pool. Here is a little bit more information you can see. So this is the hash of this block. You can also see the parent hash, so the hash of the previous block. You can see some other data, so the nonce, for example, which is this random number. This is getting guessed. So this is a number that is getting randomly guessed to meet a certain hash difficulty in order to be able to mine the new block. Yeah, this is basically all the information that is available for a block here. You can have a look at etherscan.io and can explore it a little bit. If you have questions concerning specific data fields here, please leave a comment in the section below, and I will be happy to answer them if I can, of course. And yeah, next one, I will go through transactions. I will do this right now. I was thinking about doing another video, but I think we are 7 minutes, so we can do a transaction, can have a look at transactions as well right now. So when you go back to etherscan.io, as I said, to the left we have the latest blocks, and to the right we have the transactions. So for example, when we just go back to the same block that we had a look right now, it was, what was it? Oh, it doesn't really matter. So we can choose a new block and can click at the transactions here. And this is a list of all the transactions that are in this block. You can see some information at this table. So the transaction hash. So this is basically the identifier of the transaction. You can see the method that is executed. You can see the block in which this is included, the age, the from and the to address, so from which account to which account or to which contract. You see the value that is getting transferred, and you see also the transaction fees, and that's basically it. So maybe let's use the second one because it's a transfer event, so it's basically a ERC20 token, I guess. When we click on this, we see that the data from the table once again. So we see the transaction hash, which I said is the identifier. We can see that this is successfully added to a block. Here we see in which block. We see also the amount of confirmations that are tied to this transaction. So basically this means the transaction, so the block in which this transaction is placed, there are 5 blocks that are newer than this. And the more transactions that are or the more blocks that are appended after the block where this transaction is added, the more the blocks are. So when the list is growing, and the more blocks there are, the more secure it is, because it can't be easily changed when the list is very long already. You see the timestamp at which this is added to the block. You see, as I said, from which account to which account. You see the value that is transferred. So basically it's 0.0028, which is $3.50 or something. You see the transaction fees. You see the gas price that is paid for each gas unit that is consumed. So a transfer, it went or action takes 21 million gas. We can 21,000. Sorry. We can see this when we expand the information here. So we see the gas price that is for each gas unit paid from the one that issued the transaction, we see that this is consumed. So this consumes 21,000 gas. So this is a classical transfer, and the transaction fees is basically 21,000 multiplied by 8.13 gigaway, which sums up to this transaction fee, of course. So this is the price, how this is getting calculated. So basically, to just make a proof, we can copy this number, multiply this by 21,000, and I think here is the wrong decimal. So this is 0.12317, 0.12317, you know? So this is the transaction fee. How is it calculated? Down there we see some information that are kicked in with AEP 1559, as I told you. You see also this information here. So this is a transaction that is based on this improvement protocol. So where a little bit of a fee is getting burned, so Ether is getting burned in order to keep the gas price more stable and to increase Ether on the long run, also the value of Ether. You see how much is getting burned here, and basically it. So this is some input data you can send along with a transaction, but this is a transfer event, so there's nothing put in. And so I have to correct myself. I think I told you that this is an ERC20 transaction, but this is wrong. This is a classical Ether transfer. So from an address to an address, and we can also click on these two addresses. I open it in a new tab, and we can see how much balance they have and what other transactions they made so far. So I will go through this in a separate video, but just to show you that these are two externally owned accounts. So two basically persons, more or less, that are in control of these accounts, and where one person sent $3.45 to another person, and this cost $0.21. And here's all the information. You can see everything on the blockchain, and there's an input data field, as I said. This is taking place when you interact with a transaction, with a contract, with a smart contract. Then you would see here the identifier of the method of this contract. But I will also go over this in a separate video. I think I will make 3 videos out of this series. So this one for the blocks and for the transactions, another one for accounts. As I said, when we click here, we have all the states of an account, of an address, of a person, more or less. And there are also smart contracts where we can review the code that is stored and on-chain stored. And I will also show you this in a separate video. I hope you get something out of this. It was interesting to see how you can navigate and how you can read the data, basically. So this is the thing that I want to give you, how you read the data from the blockchain or from a block explorer. So Etherscan is a block explorer. And how you do all that, how you read that, how you understand that, and how this is all interconnected. So stay tuned for the next one, which is about accounts and externally owned accounts and addresses. And after that, as I said, we will jump into smart contracts and we'll read smart contract data there. And I hope you like it, and hit the like button below. Leave a comment in the section if you have any questions, and see you next time.